Hello everyone. Welcome to the next lecture on examples of the two-point Gauss quadrature formula. Myself, Dr. Harish Garg. You can follow and subscribe my YouTube channel. Now, what we have discussed so far, we have learned the concept of the Gauss quadrature formula, which is the extension of the Newton's chord formula and defined by equation number 1. In this equation number 1, the parameters lambda I is known as the weight and xi is called as the positions, or you can call as the node of the node of the domain -1 to +1. And make sure students, in the Gauss quadrature formula, both the parameters lambda I and xi are unknown to us. Since our target in this lecture to understand the concept of the two-point Gauss quadrature formula, and this two-point Gauss quadrature formula is the extension of the trapezoidal rule. The formula which we have derived in our last lecture for the two-point Gauss quadrature formula is defined in equation number 1. For more detail, you can watch the lecture of two-point Gauss quadrature formula concept and derivation in this lecture. You can watch the concept of the Gauss quadrature formula and the derivation of the two-point Gauss quadrature in our last lectures. Now, but you have to make sure that whenever you want to apply the two-point Gauss quadrature formula, your domain must be from -1 to +1. But if your domain is from A to B instead of the -1 to +1, then your target is to convert the domain is from -1 to +1. And once, how you can change them? Definitely we can use some substitution, and that substitution we can use as x is equal to b minus a divided by 2 of u plus b plus a over 2, where b and a are the lower limit and the upper limits of the integral. Now let's start with the 15 plus numerical example in this lecture. So before I can start the first example, I hope you can like and comment on this video as well. If you are new to my YouTube videos, you can subscribe my YouTube channel as well. Now the first example. Compute the integral by using the Gauss quadrature two-point formula. First of all, you can see my domain is -2 to +2. So your first target is to convert the domain from -2 to +2 to -1 to +1. What is the A? A is my lower limit, B is my upper limit. Fine. And your target is to convert that integration from A to B to -1 to +1. So for that case, you can use the substitution. X is equal to B minus A divided by 2 into U plus B plus A over 2. I can substitute the value of the B. I can substitute the value of the A. It is 4 plus 0. So that means X is equal to 2 into U. Fine. Now since we need a dx also, can you find the value of the dx? Dx is my twice of du. Now you can substitute the values in the given integration. The domain is from -1 to +1. I can substitute the value of the x is my 2 into u. It is minus of u. Dx will be twice of du. I can take in 2 is my outside. Then -1 to +1 minus of u into du. Fine. Now you can see that domain is my -1 to +1. Then you can apply the two-point Gauss quadrature formula. And then what is the two-point Gauss quadrature formula? Here you can see that 2 is outside. So I can write that 2 is outside. The formula for the two-point Gauss quadrature formula is f of -1 by √3 plus f of 1 over √3. Fine. The Gauss quadrature formula is applied on this side and 2 is outside, which is written. What is the fx? So now you can see the f, or you can write as a u. F of u will be the coefficient of du, that is e raised to power minus u. Now you can substitute the value. This number will be e raised to power minus plus, and it's e raised to power -1 over √3. After the solving, you can substitute the value, you can use the calculator, and you'll get the answer is 4.6853 is the right answer. Look at the second one. Again, A will be 0, B will be my 1. Fine, which is, so your target is to change the domain from a comma b to -1 to +1. Again, I can use the substitution b minus a over 2 into u plus b plus a over 2. So what is the value of the b minus a? It is half of u. B plus is half of u. So I can say x is my u plus 1 over 2. What is my dx? Dx will be half of du. Now you can substitute in the given equation. So that number will be -1, 2 plus 1, 4 plus twice. What is the value of the x? X is my u plus 1 over 2 into half of du. I can take an half is outside. It is 1, 2 minus 1, 4 plus twice cos of u plus 1 divided by 2. Then you can apply the 2. Now the domain is from -1 to +1. So I can apply the 2-point Gauss quadrature formula. Half is outside. So it's a half and so on. Can you find the value of the f of u? So f is my this component 4 plus twice cos of u plus 1 over f क्या होगा बच्चों जो भी आपका इंटीग्रेशन के अंदर लिखा हुआ है that is always your f of u. Now you can substitute the value. It is half 4 plus twice cos of -1 over √3 plus 1 divided by 2 and 4 plus 2 cos of 1 by √3 plus 1 over 2. After using the calculator, you will get the answer is 5.68253 is the right answer. Kindly like the video, students. Now in this case, you can see the domain is already -1 to +1. So you can apply directly. If I taken this number is my I, you can, because there is no coefficient, you can apply directly f by the 2-point formula. Fine. So can you find the value of the f? F will be 1 over 1 plus x. Because the domain is already -1 to +1. There is no need to convert into -1 to +1. So that will be 1 over 1 plus x square. So if you square them, it is 1 over 3. If you square them, it is again 1 over 3. So that will be 3 over 4 plus 3 over 4. 4 is LCM, 6 over 4. That means it's a 1.5 is the right answer of the problem. Look at the next one. Compute the integral by using the 2-point Gauss quadrature formula. Again, the domain is not -1 to +1. So we can write a is my lower limit, b is my upper limit. And your target is to convert the domain to -1 to +1. Fine. So I can convert that interval 0, 1 to -1, +1 by using the substitution b minus a over 2, b plus a over 2. So what is the dx? Dx will be half of du. Fine. You can substitute in the given equation. Your integration becomes -1 to +1 x. X will be u plus 1 over 2 and e raised to power u plus 1 over 2 half of du. ये आप चेक भी कर सकते हो लिमिट्स -1 कैसे आएगी. You can see whenever x will be 0, can you find the value of the u? When x is 0 and if you solve them, u will be -1. And whenever x is 1, then clearly say u will be 1. Otherwise, कोई जरूरत नहीं है, you can write it directly as well. Fine. Now you can see this half is my outside. Then your I will be half is outside. Here half is outside 1 by 4. Now you can see the domain is -1 to +1. So you can apply the 2-point Gauss quadrature formula. What is the f? F is a portion which is inside the integration. This is my f. U plus 1 e raised to power u plus 1 over 2. So I can substitute the value. 1 over 4 is outside. U -1 over √3 plus 1 e raised to power -1 over √3 plus 1 divided by 2. Similarly, for second part, u plus 1 e raised to power, and after using the calculator, you will get the right answer is 0.99825. Next question is compute the integral. Again, you can see the domain is not as -1 to +1. So I can change the intervals from 0, 1 to -1, +1. So it is b minus a, half of u, b plus a divided by 2. So therefore, dx will be half of du. I can substitute the value in the given equations. Domain is my -1 to +1, 1 over 1 plus x into half of du. If you take the LCM, 2 will be the LCM, that will be cancelled out. It is 1 over u plus 3 of du. Fine. Now you can apply the Gauss Quadrature formula. 2 point. What is the f? F will be 1 over u plus 3. So you can substitute the value -1 over root 3 plus 3 and 1 over root 3 plus 3. After using the calculator, you can get the answer is 0.6923 is the right answer. Always student calculate the answer up to the 4 decimal places. At least you can calculate at least 4 decimal places your answer. Look at the next one. Compute the integral by using the 2-point formula and also compare it with the exact value. First of all, domain is not from the -1 to +1. So I can change the interval 1, 2 to -1, 1. So can you get the answer? What is the b minus a? Is a half of u, b plus a over 2. So therefore, what is my dx? Dx will be du divided by 2. I can substitute in the given integral. So the domain will be from -1 to +1. 2 into x. X will be u plus 3 over 2. This is x divided by 1 plus u plus x divided by 2 raised to power 4 and du divided by 2. Fine. So half will be outside and I can open this bracket. It's a 64 and this 2 will be cancelled out. 2 raised to power 4 is a 16. Fine. Now my domain is from -1 to +1. I can apply or you can take it as LCM. For better take, you can take the LCM. Now by using the Gauss Quadrature 2-point formula, what is the f? F will be 8 into u plus 3 divided by 16 plus u plus 3 raised to power 4. Fine. So or what is the -1? It's a 0.57735 and so on. You can substitute the value in the given f. After the solving, you will get the answer is 0.54337. Now look at the second part. Compare the value with the exact value. What is the exact value means? You have to solve these integrations by directly. How you can solve that? It's a very simple. Because it's a 2x, so I can substitute x square is equal to t. Then 2x dx is equal to dt. Then your integration becomes when x is equal to 1, t is equal to 4. It is a dt divided by 1 plus t square. Is it okay? By substituting x square is equal to t, you will get as. So can you solve this integration? This is my tan inverse of t from 1 to 4. So what is the answer is tan inverse 4 minus tan inverse 1. So now you can solve. Make sure student, once you can use the calculator, your all answer will be in the terms of the radians. Set your calculator in terms of the radians, not as a degree. Remember, you have to set your calculator as a radian, not as a degree. Now after the solving, you will get as 0.54041. By using the Gauss-Legendre formula, the answer is 0.54337. So you can see there is an error. So what is the error is? Exact value. This is the exact value minus, this is the exact value minus of the approximate value. Always remember, whenever we are trying to solve by the Gauss-Legendre formula, we always get the approximate value. Fine. And this is called as the exact value. So the error will be 0.00296 is the right answer. Compute the integral 0 to pi by 2 by using the Gauss 2-point formula. Also find its true error and the absolute error. First of all, I can convert the domain a comma b to -1 comma 1 by using the substitution b minus a over 2 and b plus a over 2. What is a b minus a over 2? It is pi over 4, and b plus a over 2 is pi over 4. Therefore, the dx will be pi over 4 into du. I can substitute in the given integral. Integration is from -1 to +1. Sine of x. X will be pi over 4u plus pi over 4 into du. So du is pi by 4 is outside into du. Fine. Now the domain is from -1 to +1. I can apply the Gauss-Legendre quadrature 2-point formula. What is the f? F is my sine pi over 4 plus pi over 4 into u. So it will be pi over 4 sine pi over 4 minus pi over 4 root 3 plus sine pi over 4 plus pi over 4 root 3. Now make sure once you can calculate this value in the calculator, you can set your answers in terms of the radius always. Fine. So after the calculation, you will get as 0.99847. How you can find the error? So we need to firstly find the true value. So can you find the true value? So I can firstly find the true value integration of 0 to pi by 2 of sine x. This is my exact value. I can write this number is exact value. Fine. So what is the integration of the sine x? It is minus of cos x from 0 to pi by 2. So cos of pi by 2 is 0, minus minus plus 1. So the exact value is my 1. Therefore, the true error answer will be exact value minus approximate value. What is the approximate value is 0.99847. 0.99847. After this subtraction, you will get answer is 0.00153. Similarly, you can calculate the absolute error or absolute relative error. That means it's a true error divided by the true value. So it's a 0, 1, true value minus absolute value divided by the true value. True value is my 1. And if you write in the percentage, answer relative error is 0.153 percentage. Next question is compute the integral by using the 2-point formula. Again, your target is to firstly convert the domain from -1 to +1. I can use the substitution b minus a over 2, b plus a over 2. Therefore, dx will be du. Now you can substitute the value. Your integration becomes -1 to +1 x square u plus 1 square minus 3 times u plus 1 plus of 2 dx will be du. Now you can solve these integrations. If you little bit simplify, that number is u square plus 2u plus 1 minus 3u minus 3 plus 2. Fine. Now you can see 2 plus 1, 3, 3 and 3 cancel. So that expression becomes u square minus u. Fine. Now you can apply the Gauss Quadrature 2-point formula. So what is that? It is u square 1 over 3 minus minus plus plus f of plus is a 1 over 3 minus 1 over root 3. So that number will be cancelled. Answer is 2 by 3 is the required answer of the problem. If somebody will ask you calculate the error, fine, you can find the exact answer. That is x cube by 3 minus 3x square by 2 plus 2x This is the exact value. Fine. After getting the exact value, you can subtract from the approximate answer, you will get the error. Look at the next one. Evaluate the integrations by subdividing the interval 0, 1 by dividing into the two equal parts. So you have to divide into the two equal parts. So can you get this number? So definitely it will be half. Why? Because you can see this length is my half and this length is also half. Clear? So therefore you can divide this into the two equal parts. So it will be 0 to half and half to 1. Fine. So I consider the first integration as a I1, second integration is I2. Now you can divide into two parts, and then by using the Gauss-Legendre 2-point formula. That means your target is to evaluate I1 and I2 by using 2-point formula. Fine. So let's start with the firstly I1. Again, the domain is not as, in this case, A will be 0, B will be half. So I can use this substitution B minus A over 2 into U, B plus A over 2. So what will answer is 1 over 4 into U plus 1 over 4. Therefore, dx will be 1 over 4 into du. Fine. Now you can substitute the values. So I1, it will be integration from -1 to +1. Sorry, -1 to plus half. Sorry, -1 to +1. Fine. This number is my I1. Fine. 1 over x will be my u plus 1 over 4. And it's a 1 over 4 into du. So if you take the LCM, 4 will be cancelled. U plus 5 of du. Now you can apply the 2-point Gauss quadrature formula. It will be 1 over minus 1 over root 3 plus 5 and plus 1 over root 3 plus 5. You can solve this by using the calculator up to at least 4 decimal places. You will get I1 is 0.405464. Similarly, for the I2, A will be my half, B will be my 1. So I can use the substitution B minus A over 2 and B plus A over 2. Therefore, dx will be 1 over 4 into du. Fine. Now you can substitute the value in the I2. You will get 1 over u plus 7. By using the 2-point Gauss quadrature formula, your answer will be 0.287682. Substitute the value in the I2. Once you can get the addition, you will get the final answer is 0.693146 is the right answer. Okay, look at this another one. Compute the integrals by using the 2-point Gauss quadrature formula. A is my 0.1, B will be 1.3. So your target is to convert to -1 to +1. So I can use the substitution B minus A divided by 2. So B minus A divided by 2 is 0.6. B plus A divided by 2 is 0.7. And then dx will be 0.6 of du. Therefore, I will be -1 to +1, 5 into x. What is the value of the x is? 0.6u plus 0.7. E raised to power minus of 2x. If you multiply by 2, it's a minus 1.2 plus 1.4 into 0.6 of du. Fine. So 5 into 0.6 is a 3, -1 to +1, 0.6 plus 0.7, e raised to power minus 0.12 minus 0.14. Fine. So that's the value of the I. Now the limits are from -1 to +1. Again, we can use the Gauss-Legendre 2-point formula. You can substitute 3 is my outside. Fine. F of, so it's a minus 0.6 divided by root 3 plus 0.7 e raised to power minus 2 into 0.6 is a minus root 3 plus 0.7. Similarly, for you can write for the positive component. And after the solving, you will get answer is 0.91018 is the right answer. If somebody will ask you calculate the true error and the absolute error for this case, you have to solve exact value. How you can solve the exact value? So I can solve the integrations. So it will be, so because these are integrations, so what I tell you, this is the first function, fine. So how you can solve the integration in a very simple manner? You can write the polynomial and it's a e raised to power 2x. Find the derivative of this component until it becomes a 0. 5x derivative 5 and then 0. Find the integration on the right hand side. In this case, we can use the integration. In this side, we can use these are shortcut tricks. How you can solve the integration. Fine. So integration is e raised to power 2x divided by minus 2, e raised to power 2x divided by plus 4. And then the answer will be, you can multiply them, cross multiply with the sign of positive, negative, positive, negative. So the answer will be, if you multiply them, it's a minus 5 over 2x e raised to power minus 2x minus 5 over 4 e raised to power minus 2x. Limits are from 0.1 to 5.3. Otherwise, you can use as integration of u into v. Fine. First function, integration of second, minus derivative of the first function, integration of the second function. Fine, choice on your side. Otherwise, this is the best way you can solve the integrations by parts with the help of this shortcut tricks. Now you can substitute the upper limit and the lower limit. You will get answer is 0.89386. Because calculators are allowed in all the examinations, so you can solve this. You can substitute the upper limits and lower limit, get the answer. Now, can you get the true answer? So true error will be exact answer minus approximate answer 0.91018. So if you substitute them, your answer will be minus 0.1632. Can you find the relative error? So relative error will be the true answer 1632 divided by the true value. What is the true value is 0.89386 multiplied by 100, or you can write in terms of the absolute value. So your answer will be 1.825658% is the error, absolute error of the problem. Now this is the way you can see all those 2-point formula of the Gauss-Legendre formula. We will see the 1-point Gauss Quadrature formula derivation plus several numerical examples in our next lecture. Till then, you can share this video with your friends, like and comment on this video. Happy learning always, students. Best wishes. Thanks for the watchings. Good luck.